Rules of indices, Part 1. Powers and indices are the same thing, and the singular for indices is index. So let's have a look at some of these rules. So the first rule is multiplying indices. When you multiply indices, you add their powers. That looks like this. So x power of a times x power of b, you add the two powers together, which is x to the power of a plus b. Let's have a look at an example. So if we have a to the power of 4 times a to the power of 3, we add the powers together, and that will give us a to the power of 7. Now if we were to look at the proof of that, you would see that you have a times a times a times a, which is a to the power of 4, multiplied by a times a times a, which is a to the power of 3. So altogether, that is 1, 2, 3, 4, 5, 6, 7 a's times together, hence the answer is a to the power of 7. Here's another example. So 5 to the power of 2 times 5 to the power of 7 gives you 5 to the power of 9. Now for the next example, they actually want you to calculate. Therefore, 2 to the power of 3 times 2 to the power of, if it's by itself, is power of 1. You add the two powers together, so 3 and the 1 is 2 to the power of 4. And to calculate that, you then have to work out 2 to the power of 4, which is 16. Our next rule is dividing indices, and you subtract the powers. It looks like this. So you have x to the power of a divided by x to the power of b, you subtract the powers, so it's a minus b. Let's have a look at an example. So you have a to the power of 5 divided by a to the power of 2, which gives you 5 minus 2, which is a to the power of 3. And if we were to look at the proof of that, you would see that if you write it as a to the power of 5 divided by a to the power of 2, you can see that you can cancel out some of the a's, which will give you the answer of a to the power of 3 over 1, which simplifies to a to the power of 3. Let's have a look at another example. So we need to simplify and write in index form. So we're going to subtract the powers, 8 minus 2. That will give us 9 to the power of 6, which is your answer. And then we have another one. And again, this time we have to calculate. So first thing we'll do is we'll work out 7 to the power of 6 divided by 7 to the power of 4, which is 7 to the power of 2. And then if we calculate that, the answer is 49. We're going to have a look at some further examples. So the first example we're going to look at, we have 5a to the power of 7 times 3a to the power of 6. And what we're going to do here is we're going to multiply the numbers together separately, and then we're going to multiply a to the power of 7 times a to the power of 6 separately as well. So if we rewrite it, so we have our numbers together, and then we have our a's together. Don't forget, in between the 5 and the a there's an invisible times, so all I'm doing is rewriting this multiplication. So when I do 5 to the power of 3 and a to the power of 7 times a to the power of 6 separately, we get 15 and a to the power of 13. So the final answer is 15a to the power of 13. And let's look at another one. Now when you first look at this, it looks quite confusing. However, it is only asking you to simplify, so if you can, simplify it. We can see that these two terms are the same, so we can use our indice rules. So let's do that first. So we have the power of 8 divided by the power of 5, so we're going to subtract these powers, which gives us x minus 2 to the power of 3, and then we're going to use our indice rules for these two terms. So whenever we times, we add the powers, so that becomes y to the power of 11. So when we put that all together, our final answer is x minus 2 to the power of 3, y to the power of 11. The next rule we're going to look at is whenever you raise an index to another index. When that happens, you multiply the powers. It looks like this. So you have x to the power of a, and then it's raised to the power of b, so you simply multiply these two together. For example, p to the power of 4 raised to the power of 2, when you times these two together, you get p to the power of 8. Now if we were to look at the proof of that, you have p times p times p times p, which is p to the power of 4, and then you square that, so you're going to multiply it by itself. So there's your p to the power of 4 times p to the power of 4, and you can see all together we have 8p, so that's p multiplied by itself 8 times, so that means it is p to the power of 8. Let's have a look at another one. So we need to simplify, so we're going to simply multiply these two numbers together, and we get 5 to the power of 21, and we want the answer in index form, so we leave it like this. Then our next example, we have to calculate. So once we do 3 times 2, which gives us 2 to the power of 6, we then calculate this, which gives us 64. The final rule we're looking at in this video is anything to the power of 0 is always 1. So that looks like this. For example, 4 to the power of 0 is 1. So let's look at the proof of that. So we're saying that 4 to the power of 3 divided by 4 to the power of 3, we subtract those powers, we get 4 to the power of 0, which we're saying is 1. So if you write it out like this, you will cancel the 4s on the top and the bottom with each other. And then whenever you times 1 times 1 times 1, you get 1. And 1 times 1 times 1, you get 1. So that's 1 over 1, which is 1. Or you can look at it as 4 divided by 3 divided by 4 divided by 3. When you divide something by itself, the answer is always 1. Now it's your turn to answer some questions. Pause the video, then have a go. How did you get on? Here are the answers. If you answered any incorrectly, have a look back through the video and then have another go.